Good afternoon. Oh, it's warm in here, and I was on the bike ride yesterday. I think I am currently winning the contest for the shiniest person in the room. Feel free to come and compete with me if you wish. Although I have to say I was cycling behind Jeff yesterday, and I do think I was getting the full glare of the reflection as well, so double radiation, but there we go. Who knew that Berlin could be that dangerous? MVVM-C in practice. Okay, I understand that it's quite hard to read code on this screen, so the slides are just there. If you want to follow along on there, I've changed things to black and white, so hopefully you'll be able to see it, but if you can't, then you can look at it a little bit later. I'll just give you a couple of moments to download those. I have to say that the live captioning is really, really impressive. It's great to watch that going on and how good it is. But yeah, please do. But it does make it incredibly tempting to say things like supercalifragilisticexpialidocious. And I can't see it. Okay, so maybe I should tell you. Okay. I'm assuming it worked. Let's try this one then. Maybe I should tell you about the childhood holiday I had in the little Welsh village of Llanfair Pwc Gwyngyth Gogerin with Llantysilio Gogogok, which is a real place, by the way. No, well, we'll give them 20 minutes to do that one. Okay, I appreciate this is, it's after lunch. The sugar crash is beginning to kick in from all the food at lunchtime. There's going to be code in this talk, so sleeping is a strong possibility. So before you go off for your nap, just listen to this little bit, just for 1 minute, and then you can have as much snooze as you like. This is a talk about some experiences and some opinions. It is not about a mantra or a religion or something that you must do, otherwise you're an idiot. This is just about some experiences I've had, and maybe you can or can't learn something from it. Maybe it will be interesting, maybe it won't. But all I'm trying to say is I'm not really interested in having a religious war with you on Twitter in 30 minutes' time. So I just wanted to point that out. Okay, so I started looking at MVVM with a C a little while ago when I was looking at a project that had to work mainly on the Mac and iOS. So I wanted to share as much code as possible. So I was looking to start this project. It wasn't a huge project, with a number of goals. And those goals were to use as much code as possible in both applications. It didn't matter to me whether that was in frameworks or whether it was just got compiled in, but I wanted to share as much code because functionally the apps were very similar, although visually often quite different. I wanted there to be good test coverage of my code. And not only did I want good test coverage, I wanted those tests to be easy to write. I didn't want to have to fight the system in order to write tests around there. And finally, I wanted to be flexible because this code needed to be used in both applications, yet the workflow in the different applications might be different. So I didn't want the code to be locked into any particular workflow or way it had to work. So as much as possible, things could be plugged in where I wanted them in an application. And so I began to look at how could I put this application together to do that without going crazy and doing stupid things like reactive programming. Did I really just say that out loud? Never mind. Okay. No, nothing yet. All right, so this is green is the new orange. We all know, hopefully, about this thing called Model View Controller. And Model View Controller has got a really bad rap in the last sort of year or two. People call it rude names like Massive View Controller and things like that. However, it's maybe because it's all taken a little bit too far and a little bit too religiously. I'm going to keep using that word because it seems to happen a lot with patterns. You see, because the whole idea behind Model View Controller was simply a separation of concerns. Separate your code in a way that makes sense, that things that shouldn't be together aren't together, and things that should be together are together. And it actually, over the years, has turned into this huge argument about what should go where, and this should be that, and whatever else. But actually, a lot of the problems we have is because the default implementation of what we call Model View Controller within Cocoa and Cocoa Touch is the UI View Controller, and then whatever else you stick behind it. And it's a really bad implementation of MVC, because it doesn't really do the job. The controller is supposed to be separate concerns from the view, and yet the view controller is so tightly coupled to the view that it causes a whole bunch of problems. And I'm sure we all know that testing view controllers is difficult, and we've all tried lots of different things to try and make testing and using this paradigm easier. But I think if we're ever going to get anywhere in achieving some of these goals that I've put out there, we have to come and accept the fact that actually UI view controller is just part of the view. It is the view. It's not a controller. It's not a model. It is just part of the UI. And the faster we begin to just learn to accept it is that way and treat the UI views and UI view control together are the view part of my app, we will begin to get ourselves out of a whole bunch of problems. Okay, so UI view controller and UI view, presentation of data and user input makes a lot of sense. This thing that in MVVM is called the view model is what we would have called controller in MVC. Now, if you look at MVVM, model, view, view model, it's actually just 3 separations of concerns, just like MVC. So I am going to argue that MVM is just MVC with different letters. Ish. If you take it pragmatically. Okay. However, whether you go for MVVM or you go for MVC, there is still a problem if you're looking for this flexibility, you're looking for this code reuse type of thing, is neither of the models cover navigation very well. The moment you begin to put navigation code into, it doesn't matter, your view controller or your view model or, heaven forbid, your model, you begin to create a whole bunch of couplings that are just really not good for code reuse and whatever else. So we needed another concept as well, or I felt I needed another concept, and I just chose to call those coordinators. And they take all responsibility for the navigation and flow within the app. So you should never find within a view model or a view anything that dictates what happens next after that view has done its job. That is the job of a coordinator or something else. So I've put together a little demo app, which we're going to talk our way through, just to see some of the approaches I took in this, and so that you can laugh at my code and you can throw things at me and whatever you want to do. Okay, so the app will start with a login screen. I got my best designers on this. Paid them a lot of money, okay? The app starts with a login screen because every app should have a login screen. Okay, just something that I believe in. Okay, because when you log in, okay, you want to protect your sensitive data. In this case, it's my crew. So when you log in, you get a list of the crew, and if you tap on any one of those cells, you get their comprehensive employment record that goes with it. If you click the done, it goes back to the list. It's a pretty straightforward demo app. Nothing key in there at all. And so we're just going to walk through a few of the principles used putting this together. But before I do that, public information announcement. We'll come over here just so you can see the separation from the message. Protocols. How many people here have sort of been experimenting with protocol-oriented programming? Wow, that's pretty good. How many people think it's a good idea after experimenting with protocol-oriented programming? That's slightly less, okay. How many people are still doing protocol-oriented programming? Okay, not as many as said it was a good idea, so that's interesting. Who knows? Statistics, you can make them say anything. Protocols, whether you're using Objective-C or using Swift, protocols are just an amazing way of giving yourself flexibility. A protocol is just a contract that says that I want to throw anything I like at you, but I guarantee it will support this. And it gives you such flexibility. So for myself, whenever I'm creating a property that is going to link something, whenever I'm creating some data that has to be passed to something, my first question is, should this be a protocol? Do I want to really lock myself into a particular struct or a particular class when I can actually just lock myself into a contract, which I'm happy to meet in whatever way? So protocols, we should be, if you're not doing it yet, do examine using protocols, even if you're using Objective-C. I mean, it's not like they're new to Swift. There are differences. Protocol extensions in Swift 2 make life pretty good, but Objective-C has optional parts of protocols as well, which are powerful. I know you can have optional protocols in Swift as long as you put the obj-C keyword on there, but I have to be honest, every time I put the obj-C keyword in a piece of Swift code, it feels like I've given away a little bit of my soul, so I don't tend to do that. Right, so let's start with views. UI view controller. The job of the view is to present data and to collect data. That's it. It has no other job. It's not its job to decide what data to present. It's not even its job to decide the format of the data it's going to be sent. It's simply to be a dumb presenter and a dumb collector of information. And the reason for this is partly because anything you do with a UI view and a UI view controller, you're locked to the iOS app. This code can't be used in your other application, the Mac app, because it's there. So really, I look for my view controllers to have as little code as possible in them, as dumb as they can be, which means they actually need to get their information from somewhere. So in the case of MVVM, that comes from a view model. It's the view model's job to provide data. So if we just look at the login screen for our application, we could see we have a password field, we have a username field, and we have a login button. So what might happen in this particular view controller is when we set a view model property, we'll get a function called setDisplay, and it just sets up the screen. I mean, bulk standard code. We're probably doing something very similar anyway. We just don't happen to give it trendy names, but that's what it's doing. Equally, on the other side, when we type into our password field, or we type into our email field, or we click the login button, it simply passes on what it's got. It just passes what it's on to the view model. It doesn't do anything else. That is virtually the entire code for the view controller in this instance. And anything else in there really has to be questioned. Now, in the MVVM world, there's a lot of discussion over whether view models, these things that are going to provide the data, should be immutable or mutable. Okay? And if you enjoy arguments late at night on internet forums, this is a good one to pick. It will keep you busy for a long, long time. There is plenty going on. So the idea, if you have an immutable view model, is that any time the data is changed, you just replace the entire view model. The view will spot that you've replaced the entire view model, it will run that set display, and it will do its thing. When you have two fields like this and just a status, that's pretty cool, not a problem with that. If you've got 300 fields on a form, find a different designer. But after that, if you still have to implement that, do you really want the whole view to refresh just because one field is changed in your view model? And equally, if you make the view model immutable, where does the data I collect from the fields go? So now I'm going to have somewhere else for the data I'm collecting from my password fields to go, and all that is actually going to do is create a new instance of the view model and pass it back anyway. So in my case, I decided that actually the view models could be mutable. But the moment you create a mutable view model, you have the issue that what happens when the data changes? Okay, how does the view now know when the data changes? So there are several ways to do this. You could use KVO. That's not a bad option, apart from I loathe KVO with every fiber of my body, but other than that, it's not a bad choice. I don't hate KVO because it's a bad technology. I hate KVO because of what developers do with it. When you work on lots of different code bases and you see how KVO is implemented in some places, it's enough to make you not sleep at nights, I assure you. KVO also pushes everything back through just one method, which is a little bit messy. Could use notifications. Troubles with notifications is, I believe, notifications should only be used when any part of the app might need to know that something has happened. Whereas in this case, that's not true. Only our view is ever going to want to know what's happened. So we have a good old-fashioned pattern in Cocoa we've been using for years from day one. Let's just use a delegate. So in my code, you'll see that all view models have what's called a view delegate property, and that can take a view delegate type, which will be implemented by the view controller, and anytime data changes in the view model, it calls the appropriate method. So let's just quickly look at the code. I don't expect you to read all this code right now. This is here so that when you go back to the slides later on or look at the video, you can take it over. So this is our authenticate view model view delegate. It's just got two routines in it, one saying that the error message has changed and one saying that the status of the can submit button should change. In our view model, our view controller, we just implement the delegate methods so that when things change, it puts them and it changes the data. And that's it. Okay, so it's all code you've written before. It's nothing new in there. So let's take a look at the view model itself and how that works. Okay, so if you remember, a view model, its idea is to get data from the model and put data back into the model. It's not actually supposed to access data personally itself. It's supposed to provide an appropriate data view for the view controller to use. It's quite good that you use view models to present data in a way that makes sense to the view, not necessarily the way it comes from your database or it comes from your JSON or comes from wherever else. The view should not really care. It should just see data the way it wants to see it. So the view model is a place where that translation can go on. Equally, it's where we implement business logic, and it's where we might communicate our state to a coordinator. I'll come back to that one. I won't explain it right now. Okay, so here's our view model declared as a protocol. As you can see, it's just a few parameters and functions, nothing particularly surprising there. But we do have three properties: a model that it's going to take to access data, a view delegate, which is going to be used to communicate back to the view, and then it has this thing called the coordinator delegate, which is going to use to communicate with the coordinator, which we'll talk about in a minute. Because we're doing this, when we use properties, we have to make sure that if something's changing, that we actually call the delegate methods. That actually turns into quite a lot of code you write quite a lot of times. We don't like writing code quite a lot of times as developers. However, this code is simple. This code is easy. This code is readable. Equally, this code produces a nice stack trace in a debugger because it's being called properly, whereas simply throwing having KVO connected or throwing a notification, it all becomes a little bit more of a mystery. So is this code incredibly boring and frustrating to write? Yes. Is this code incredibly easy to read and understand? Yes. Is it one of the simplest solutions and therefore probably a good one? Yes. I wasn't expecting you to answer. I knew the answers. I was telling you as well at the same time. If you felt free to disagree, you just missed your chance. There we are. You should have been a little bit more on the ball, but it's your fault. There we go. Okay, so let's look at this method. This is far too much code to go through here, but let's do it anyway. Okay, this is the submit button. This is what happens when I press the login button, and we're not going to go through all the details of it, other than to point a couple of things out. It accesses data through its data model. So the view model itself never accesses data, or it doesn't matter whether it's on the disk, whether it's from the network, whether it's from NS user defaults. A view model should never access data itself. It should always ask a data model for it. Okay? And you notice that after it's done something in the data model, testing it to log in, it has a completion handler, and that code was this in that submit button. And basically, it's saying there were no errors, we're done. Now, normally, or often in a view controller or whatever, this is where we'd say, okay, the login screen has done its job. Let's load the next view controller into the navigation controller or change the root controller or whatever you're doing at that point. But remember I said that view controllers and view models and models should never determine application flow because it immediately creates a connection that you can't change. So all that is happening here is whenever a view model, and I've chosen to normally do this in the view model, has done its job, it merely tells the coordinator, which we haven't looked at yet, so you're going to have to trust me on this, that's responsible for it, I've done my job. So it's really holding its hands up saying, I've done my bit. If the app doesn't work from now on, it's not my fault. It's your fault because I've done the login, which is what you asked me to do. And then it's a coordinator that will decide what happens next. So by taking this approach, I can drop this view model in anywhere in my application flow because it's never dependent on where it's going next or where it's come from. Okay, so let's just quickly look at models. So models are there. The whole view model, the terminology is really, the words are all the same. I think we should just call them A, B, and C or something. It'll be a lot easier. The model, okay, so the job of the model is to handle all data access, getting data, saving data. I've chosen, when I implement models, to use functions, not properties. Okay, and equally, I've chosen to return all data from my model using a completion handler on a function. So no functions ever return a result. They always use a completion handler to have the results and the errors in. And when I use a model, regardless of whether it is or isn't, I always make the assumption that the function that I'm calling will be asynchronous as well. The reason to do this is quite simple, that it means that at any point I can replace the model I'm using with a view model and I don't break any code. As long as my view model follows those rules, that it's It's using functions, it's using a completion handler, it's being asynchronous, and I write the use of that view model, that model that way, then I can swap my model that gets data from the internet with my model that gets data from NS user defaults, or with my model that gets data from core data, and nothing breaks. Whereas if I make an assumption that this particular view model is synchronous and just uses properties, and then I try and change things, it all goes wrong. So it's more of a safety thing for myself. So let's just take a quick look at the authenticate model. It had one function, login, took email, password, and had the completion handler. Actually, in the code, you'll see it just hard checks a password. But I could easily, now that isn't a view model, sorry, that is a model you could then easily use for testing purposes. So when it comes to testing your view model, you just create a model that has fixed hard-coded data in it, and you can test every aspect of your view model. Okay, in the real app, you would put a different model object in there, which might do some internet access or whatever else, but you don't want to be testing that in a test environment. So we've immediately created a testable code by having no connection to the view at all in our view model, having replaceable data access for our view model, and no coupling to any other controllers within our view models. Our view models are now 100% testable. You should be able to get 100%, for most view models, you should be able to get 100% test coverage. And equally, because they're not connecting to a UI view or an NS view, and they're not connecting to any particular technology, lots of view models will suddenly become just usable in OS 10 and in iOS without any changes at all. So it sort of works. Let's just take a quick look at the model that provides the data for the list, because that's a bit different. It's not just providing one function. It has one function, just items. And you'll notice items has this thing called data item. In this application, all data is passed as a protocol. No exceptions. I define what the data should look like as a protocol. Everything then gets passed as a protocol, as an array of whatever. So in this case, oh, that's big lighting. There we are. So in this case, it's a very simple protocol called data item. In the application, in this instance, it's implemented just using a simple struct to do it. However, I could use core data, and as long as my managed object specifies this protocol, I could chuck it back a whole bunch of core data objects. Or I could be accessing JSON from the internet and using a wrapper around it and just chuck it back at my program. And as long as my JSON wrapper implemented this protocol, it would use it. So I have the freedom to just swap out my data layer in any way by not tying myself in any part of the app to a technology, a data access technology, other than in the model itself. Hopefully that makes sense, and you can see the point in that. And this is the actual instance of the model. In this case, again, it's hard-coded, which makes it great for testing. This is the one for the tests. I know exactly what data I'm going to get in back. I can use it. Obviously, you're probably not going to write apps where all of the data is hard-coded. You may do, but there we are. Okay, so that's probably all stuff you're fairly familiar with. That's stuff that you've done in some form, maybe not exactly the same way, but there we are. Okay, so let's look at coordinators. Remember, coordinators' job was to handle the application's navigation, and it's the coordinator's job to build the MVVM stack. And so it's a coordinator that basically will decide what the application should do next, and then it will build the appropriate view controller, view model, and model to achieve that. So that's basically what's going on. So how do they work within the application? Right, well, in the Xcode project, first thing I do is I remove the default storyboard. So there's nothing created by default. And then in the application delegate, I simply create the controlling coordinator class, which in this case is called an app coordinator, and pass it through the window. All fairly straightforward stuff. Actually, in this application, it's really simple. It's just an implementation of a protocol with one method called start, so there's nothing complicated in there. And in the app coordinator, the start method simply says, am I logged on? If I am, let's show a list. If I'm not logged on, let's authenticate. Pretty simple code. Okay, so let's take a look at the authentication. By the way, I don't know who does this. I mean, I love doing this, that I always implement delegates and things by doing extensions in Swift and whatever else, and it keeps code separate and nice. I love doing that. Who likes that? Who hates that? Everyone else has no opinion. That's fine. It's a good place to be. Good. I'm glad I'm on the right side, the winning side. Yes. The person who hated it, I'd like to talk to you afterwards to find out why you hate it, or you just like him being controversial, one or the other. Okay, so running out of time, let's stop waffling. Show authentication. Just creates another child coordinator, adds it to a list of coordinators the app coordinator already has, sets itself as the delegate. So a coordinator has a delegate, and that's how it speaks to its parent coordinator. So everything is being passed just through a delegate, and then it calls start again. Okay? This code here is just from when the authentication coordinator finishes, it just calls back into the app coordinator where it just gets taken out of the list, and it assumes that we've now logged on, and so it just goes to show list. Okay, so let's now look at the start method of our authentication coordinator. So we're working our way down. We've had start in the app coordinator, which decided we needed to log in, which created an authentication coordinator. We've called it start method, and this is where the code begins to become a bit more familiar. We're getting a view controller from the storyboard. We create an appropriate authentication view model. We create an appropriate authentication model. We set this coordinator to be the coordinator delegate for the view model. And in this case, we're just making it the root view controller, but you might be adding it to a navigation controller or whatever you're doing for navigation. So it's in these coordinators where things are getting put and where they're going on. So remember I said that a view model doesn't make any decisions about what happens once it's done its job. That's left to the coordinator. So that's what's going on here. Okay, so our authentication coordinator is the delegate to that view model. If you remember, when we pressed the submit button, it said I'm done by just calling a function on the coordinator delegate. That was this function. All that's happening here is actually it's passing it back to the app coordinator, which then does the code we looked at just now of doing show list. So it's all just boilerplate sort of code, but it just puts itself together. Is this sort of making sense, or am I glazing you over? There's some nodding and there's some snoring there. 50-50. Okay, what am I looking at this one for? Let's just take a look at one more very quickly. I have about 2 minutes left. This is the list coordinator. This is the show list function, in the app coordinator. It just, again, creates a list coordinator. So same principles, it's just following a pattern. The list coordinator does exactly the same thing. It just gets itself a view controller from the storyboard, creates the correct view model to go with it that it wants, creates the correct model to go with it. And you can see here it's just you swap in models, swap in view models, do whatever you like to make things work. So you could use exactly the same view and view controller with a totally different model object to get data from different databases or whatever else. It all just becomes fairly flexible. Again, replaces the view controller. The only difference is in the list coordinator to our last one is what happens when you select a cell in the list. Okay? So remember I said views don't do anything other than display data and pass on information. So when you click the cell, when the cell is selected, it does exactly what you should expect it to do. It calls a function on the view model. Okay? The view model, this is actually, because it's a navigation control, the view model doesn't have nothing to do with it. So all it's doing is saying to its coordinator, we've selected something. And then within the list coordinator, it's now just creating a detail coordinator. So we have child coordinators in child coordinators, and they work themselves back up the stack. And that might be what you're seeing if you've got a typical navigation controller going on. I know I said that very fast, but when you go and see the code, it will all hopefully make sense. Okay, so that's what happens when the detail coordinator comes back. Don't worry about that. So just a quick review. UI view controller, UI view. They are your view. Do not pretend to use your view controller for anything else. It is for the presentation of data, and it is for the collection of data. It should only pass on what it collects, and it should only display what is given. So in other words, if you need an error message to look a certain way, the view model should format it to look a certain way and just pass a string to the view. Don't, no code that makes any choices inside the... You can do what you like. It's your app. But, if you want me to give it a tick of approval, which has absolutely no value at all, but some of you may like, then that's what you have to do. Business logic inside your view model, and then your CRUD operations, create, read, update, and delete operations inside your model, which is just a plain old object. Navigation flow in the coordinators. The code for the app is on GitHub, so you can download and play it with it. Don't tell anyone, but I haven't written the tests yet, so they won't be there till tomorrow. But I always write the tests first. But time is going backwards this week, but just between us and our friends, okay? If you want to talk to me about this, do it on Twitter, and please don't forget to follow Matt Sims Sings, which is the most important thing. Thank you very much.
Scotty, thank you very much. All right. Do we have any questions for Scotty? Hey,
I used up all my time.
Look. This, yeah.
I purposely used up all my time so I could avoid questions.
No, you are not off the hook yet. So you are not off the hook.
Okay.
Hi. So if I got you right, there could be networking code in your model, right? So because when you do networking code, there's stuff like JSON parsing and lots of other things. And one could argue that should not be part of your model. What's your opinion about that?
Okay, this is an issue of terminology. Okay, what goes where, and should something be in your model or not in your model? My answer is do what's sensible. I was having a conversation with someone yesterday. I can't remember who it was now, and we're saying, you get a choice really. You could be a purist, or you can ship an app. That's the choice. And finding that balance between the two is. The key is it shouldn't, if it's something to do with networking, keep it separate from everything else. So I'm calling the model anything that accesses data. Now where that then parses the data that comes back, be that JSON or anything else, is totally up to you. What I would say though is nothing should leave that model layer that's not a protocol. Because you're now making couplings you shouldn't have. So the answer is, put it wherever you like, wherever makes sense. Just if you keep the principles of keep things separate, pass things around as protocols, don't tie anything to one thing, you can then stick it where you like. And I don't get too fussed. But that's the real cop-out answer, I know. But the answer is do whatever makes you feel comfortable. Just know why you're doing it.
Thank you.
Got through that one.
Next question?
Yeah. Here. Hi, thanks.
Where are we? Where are we? Wave.
Here.
Where?
Yeah. There.
Oh, hello.
Hi. I have a question for your list example. How do you actually implement the data source for the table view? Because I saw you passing an array of items. Like, how does that scale to like a long list of, I don't know, 50,000 items or something? You don't really want to pass that many model objects around, I guess.
No, it's in exactly the same way you would have done if you put it in your view controller.
So you have like a data source like protocol?
Yeah, it's basically, in the example we have here, because it's a small example, the view model asks the model, this is why the terminology gets so confusing, for data, and then it stores that data. The view controller just says, can I have the item at this index? Can you do whatever else? And it gives it back. Very simplistic example.
So you just ask for specific items.
But if you needed to sort of be getting data in chunks or whatever else, again, that's no different to what you would have been doing in your view controller, but now your model will ask for chunks. Sorry, your view model will ask for chunks, but your model will deliver the chunks. Does that make sense?
Yep.
Okay, if I get time at some point, I will add another example. We'll show a demo of that, but I try to keep the code as small as possible because it's about principles. Thank you.
Thank you.
Yeah. So who else?
Hey, so in your example, when you were in those coordinators, when you were storing references to child coordinators, like for a related action, you were storing them in a dictionary by string key. Is it just a personal preference, or is there a specific reason? Because it seemed like you also had a bug in one of your slides.
Sorry?
It seemed like you also had a bug in one of your slides where you were like removing a different key than setting.
Yeah, if I only had one bug, then I've got away with it.
Yeah.
Yeah, it's I can't remember why I used dictionary. It was a case of, the coordinators themselves have no ID, nothing to compare them with. I needed something with a key to get the right one back out. I just chose a dictionary for a simple option.
Okay.
It's in there, yeah. And the only reason I store coordinators in the first place is so they don't get dereferenced. So you could do that whichever way you like to do it. And the code has probably got some, the slide code might have some retention issues as well, because in the actual code, some stuff is declared as weak that wasn't in the slide code, so I did sort that out.
Okay, thanks.
Well, I mean, I could take this offline because we're running out of time, or
Yeah,
would you want me to carry on?
let's have a look. Yeah, last question.
Okay,
Last question.
make it a goodie. Best one there was. Who's doing it? I was down
Right,
here.
right.
Right in front of the camera. I can stare right
And
into the
it's
camera.
going to be the controversial question.
Okay, that's fine.
You use the delegation pattern for the model view model. Have you tried reactive programming? And if you did, you didn't choose it, why? It's like...
Okay.
Yeah.
I have looked at reactive programming and chosen not to use it, not because I hate it, but because I sort of have... I currently have a policy, which you may or may not agree with, that I will not put any third-party code in my application I'm not prepared to maintain myself. And I haven't got a clue what's going on in there. It's to be and so before I'd make a commitment of putting a framework that big into an application I then had to support for the next, what's the life of an app these days, 3 months? Which is a long time. I want to fully understand it and say, look, if this, for some reason, because there's been other reactive frameworks and no one uses them anymore, and yet there could be apps, people supporting them. So I'm not against reactive, I'm just not prepared to make that commitment until I understand it better. I use delegates in this case simply because it was a one-to-one relationship, and delegates make sense. If you're looking for multiple things to be looking at a view model, which might sometimes be possible, especially in the OS 10 world where you've got lots of things going on, then I would still probably avoid KVO and notifications, and I'd use an observer pattern of some form, because I like being able to follow the code in the debugger. I like to be able to see this, called this, called this, called this. Is it sometimes the most efficient? No, but actually that makes it really fast to debug, whereas when a notification just arrives or a KVO gets triggered, you just no idea where it's come from, what's done it half the time. So if I need multiple things, I use an observer pattern. I just have my own observer classes based around protocols again that do stuff. But I didn't want to complicate this code or any of that because it wasn't the point. Does that answer your question, hopefully? And I'm not a reactive hater. Go reactive, yay.
Okay,
thank
you very much, Scotty.